So the next system that we're going to put together for Spacefighter is our timer system. This is going to be very important for Spacefighter because there's quite a few things that are going to need to take advantage of timers. Now, in the past, throughout XNA 101, anytime we needed some sort of timing mechanism, we more or less put the timing code right there in that particular items class. Now, in this case, since we have several different places that need timing code, and I'm talking about code that looks identical throughout all of these classes, we're going to centralize it into a timing system, basically a timer class, that we can then instantiate and keep a reference to the new instantiated timer in each of these objects that are spawned. Now, we have separated timing for sprites from our timing class because, well, for the most part, most of our sprites require timing, and instead of having a reference timer for every single sprite that we instantiate for every single node, we just thought it would be nice to keep all of that encapsulated. Plus, we're not rewriting stuff all over the place. I mean, it's just written one time in the sprite class, end of story. But here, we need a timer, and this timer is going to look absolutely the same if used for enemy ships or weapons or whatever. So it's best just to go ahead and create a class and then instantiate it as we need it. Now, what kinds of things throughout Spacefighter will take advantage of timers? How about the flicker effect? We talked about with our sprite sheet that we can have damageable sprites, meaning these are textures that have a secondary texture procedurally generated where all of the pixels have been brightened, so that when an object is taking damage during gameplay, we can alternate back and forth between the first texture, which is normal colored, and the second texture, which was procedurally generated, which has the brightened pixels. So a timer that will control the flipping back and forth would be very nice. How about enemy ships? They need the ability to fire and fire and fire. Great place for a timer. Also, automatic weapons, burst weapons, any sort of fancy weapon like that, that would be another great place for timers so that timers can handle that firing effect. So,
I was just going to say real quick, the whole idea here is that the timer allows us to delay something from happening from a specified amount of time.
That's
in any
right.
case where you want to have some time pass before something happens, a timer can be very helpful because now you don't have to sit there and track time. Basically, otherwise you would have to look at, all right, what is our current time now, and count the time every time we get updates and keep checking to see if it is time for something to happen. A timer nicely encapsulates all that, so you can just say, all right, at a future time of 5 seconds, I want this to happen, and then forget about it. You don't have to worry about counting down time every single update. You just say, I would like 5 seconds, and in 5 seconds something to happen. So you put that into the queue, you wait, and then 5 seconds later, the timer gets back to you and makes that happen.
So how about this? Here's a quick update. We're going to have a field in our timer class that is going to be called time remaining. We're going to have an interval that's going to specify exactly how much time there will be remaining each time the timer is reset. So basically, it's 100% full of time to get counted down. So let me go and just jot down interval. And all timers are going to have a fire event. The fire event will be called by the timer class once our time remaining hits 0. So what's going to happen is this. Basically, we lose some time, 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 and we're finally going to hit a spot where we're out of time. And the moment that we're out of time, we're going to fire off the fire event. Now, anyone that has subscribed to the fire event will then get called upon, as Logan was just saying. So when we instantiate an object, be it whatever kind of object, and that object has a field in it for us to store a timer in, we can then instantiate a timer. We can activate that timer, and that timer is then stored. We can subscribe to its fire method, then completely forget about it. And then when it does run out of time and fires off, whatever event, or excuse me, whatever method we subscribe to it gets executed, while the timer itself gets refilled and begins counting down once again.
So with that visualization, what came to mind was was an hourglass. It's almost like you could
Yeah.
visualize time remaining as being sand.
Yep.
And you're literally losing sand over time, and interval is just a quantity of sand to refill the timer with after it runs out.
Precisely, and this is nothing new. I mean, we've seen this. We've used it in precision, and we've used it several times. So once again, the system is based upon a foundation that we've already put out there in the XNA 101 class. Now let's spend just a second and talk about how we're going to put this system together, because it's very interesting in how we're going to go about updating all of our timers. It's actually quite an elegant solution. We're going to start out by creating a static field, which is going to be a static list of timers. So here we are, a static list of timers. So let me just jot down static list. And then we're going to create a static update method. So let me just put static update inside of our timer class. I don't know why I'm wanting to put that extra line there. And the static update's job is to simply walk through each of the different guys that are in the static list. And as we're talking to each timer that's in the list, we're going to have that timer decrement its time remaining by the game times, elapsed game time, total seconds, and then check to see if the time remaining has gone below or is equal to 0. And if it is, then we're simply going to fire off our event and reset our time remaining so that we've basically flipped our hourglass back over and we have all of the sand to start draining through once again. Now, here's the interesting thing. Notice that the timer functionality depends on it being in the static list. If a timer is not in the static list, that means a reference can be held to the existing object, that timer that's been instantiated, inside some other object's field, but that timer's not running. It has to be in the static list for the timer to actually count down. And we're going to allow this by simply creating a start and stop method, instance method in our timer class. So I can instantiate a timer and put that reference into another object, weapon system or whatever, and then I can say, all right, I'm ready to start using this guy. Let's subscribe one of our methods to it, and then let's tell that timer to start. By telling that timer to start, he gets added into this list, and with him being in this list, he's going to get updated every tick. And here's how we're going to go about doing that. Remember that little class called our game class? You know, the main one. Back over here, inside its update method, we're simply going to make a call to the static update over in our timer class. We call that guy every single game update, and then we just walk through all of the timers that are in the static list and let them do their thing, count down and fire off if need be.
And that makes it much easier to manage when you're adding timers to other classes, because the only things you're worried about if you're working with the timer from the outside is to create it, subscribe to its fire event, and start it.
Yep.
That's really all you've got to do. And then if you wish to turn it off, you can always stop it. It gets removed from the list and it goes inactive until you start it again.
Ooh, and that's so important to remember, because let's say I've just instantiated some sort of game item that's going to use a timer, right? And then one of the fields in here is of type timer. So I instantiate a timer. So now I have a timer sitting there. Now I have some method somewhere in here that I want to get called when the fire event actually fires off. So I can go ahead and subscribe this guy out. And then once I start my timer, the timer gets added into the list. But here's the big thing. If I call on stop, like Logan just said, we're going to remove it out of the list, which means its time remaining is going to stop decrementing. There's no possibility of the fire event getting called, which means that this guy, there's no way he's going to get called. But the timer itself does not get disregarded and picked up by garbage collection, because we've not let go of the reference. The reference is still being held right there. So at any time inside here, we can say, all right, let's go ahead and start this guy back up again. And then we just simply call upon that timer and tell it to start, which simply throws it back into the static list. And then all of its updating gets handled thanks to the fact that we're calling the static update from the main game classes update every single game tick. It makes it a very elegant solution, meaning that, as Logan said, we simply instantiate a timer, we subscribe to its fire, and then we start it. We don't have to worry about how's it going to count down, where are we going to put that, and whose update is that code going to exist. We don't worry about any of that. Create it, fire it off, end of story. So that's what we're going to put together. This is actually very simple. It's only going to take a few minutes to code the class up, and as we work our way through it, we'll make sure that we explain what everything does. Logan, is there anything else you'd like to add to this?
I think that pretty much covers everything. The one thing I will point out is the fact, one thing that I like about having the list of timers only include active timers is that makes it a little bit more efficient, where you don't have to worry about the update hitting every timer. You only worry about it looping through known active timers.
Exactly. Excellent. Well, with that, let's go ahead and bring this video to a close and jump over into the coding of the timer class.